What do we remember about isosceles triangles? How many congruent sides does an isosceles triangle have? 2 congruent sides. Very good. How many congruent sides does an equilateral triangle have? 3 congruent sides. Good. So when we first talk about an isosceles triangle, let's get some vocabulary first. In an isosceles triangle, the angle that's created by the 2 congruent sides is called the vertex angle. So congruent side, the included side of those 2 congruent sides would be the vertex angle. The 2 congruent sides we will call legs. On the bottom is the base. And then already labeled for you are what we call the base angles. So if it's not the vertex angle, it's going to be the base angles. The base angles are the 2 angles that create your base. All right, so we've got some facts then about isosceles triangles. So when an isosceles triangle has exactly 2 congruent sides, these 2 sides are the legs. These are your definitions. Yeah, isn't that nice and easy? Huh? The angle formed by the legs is the vertex angle. What's the third side called?
Base.
The base. The third side is the base. And then what do we call the 2 angles that are formed by the base?
Base angles.
Good. Base angles. So, for our first theorem about isosceles triangles, look at that fanciness, base angle theorem. The base angle theorem states the following. If you have 2 sides, so if 2 sides of a triangle are congruent, then the angles opposite them will also be congruent. So if we had to make a picture of what the base angle theorem would say, here is your isosceles triangle. You've got 2 sides that are congruent. Yeah,
That's pretty good.
that's not too bad, huh? There are your 2 sides that are congruent. So what the base angle theorem says is that the angles then that are opposite of those congruent sides will be congruent. It's pretty much saying that if you have congruent sides, then base angles will also be congruent. Okay, if we were in CP geometry, we would be using this theorem in proofs, but we're not going to do that here.
What do you mean?
Just regular geometry. All right, next one is the converse. Quick review for midterm. What does it mean to take the converse of something?
Opposite.
Well, not really opposite. Converse of an if-then statement, what do you do?
Then
Well, yeah, you flip the if and the then, right? So the converse states if 2 angles of a triangle are congruent, then the sides opposite,
what's opposite?
I don't know, didn't apparently hit the font color when I made it. Then the sides opposite them are going to be congruent. So for our picture, isosceles triangle, if you have base angles that are congruent, then the side opposite of that base angle will be congruent to the side opposite of that base angle. Okay, so our picture kind of looks the same as the last one, it's just we're working backwards. Yeah, arrows are going the other way because you're going from congruent angles to congruent sides instead of congruent sides to congruent angles. All right, then we've got a corollary of the base angle theorem.
Kind of cool how it drops in like that.
Yeah, I must have been getting into my animations when I made this one.
Well, you had a week to do it. No.
Huh?
Did you do this like the week?
No, these have been made for a while. If a triangle is equilateral, then it's going to also be equiangular, which we already kind of knew that. And if we think about it using the base angle theorem, if I make my two base angles down here on the bottom, where are my two congruent legs? Left, right, bottom, left and right, right? If I make this my base, which means I make this a base angle, then where is my other congruent part? Down on the bottom. So if all your legs are the same, then all your angles have to be the same, because all your angles opposite of them is what the base angles theorem says. All right, so let's do these last three examples. Nice and easy. It says in triangle PQR, PQ is congruent to QR. Name the congruent angles. Where are your congruent base angles? Huh? P and R, very good. So angle P would be congruent to angle R. Why can I just use one letter each?
Doesn't have a transversal.
Yeah, it doesn't have like another angle coming out of P or R. Good. Does everybody see why it's P and R as the base angles?
Yeah.
Because those are the angles opposite of the congruent legs. All right, second example. Find the measure of angle X and the angle Z. So they tell me that Y is 50 degrees. Is that a base angle or a vertex angle?
Vertex.
Vertex angle. What's true about my two base angles? They're going to be congruent. So I could make them both an unknown degree, so x degree, x degree. What do all your angles need to add up to in a triangle? 180. So if I do 50 plus x, those three angles should add up to
180.
180. It's 180 minus 50.
65.
130. What's x plus x?
Wait, was I right?
2x. What's half of 130?
65.
65. So x is equal to 65. Let's put it into context. What's the measure of angle x? 65 degrees. What's the measure of angle z? 65 degrees. Good. Could we have gotten there without writing the equation? Sure. We could have done 180 minus 130 and said that is, 180 minus 50, which is 130. And since those two have to be the same, divided by 2, which gets you 265. All right, the last one throws a little bit of algebra into the mix. Find the values of x and y in the diagram. Let's focus over here with x first. What type of triangle do we have right here? Equiangular, which then means that it is also equilateral. So what's x have to be? 7. So x is equal to 7.
Wait, how do you know that?
All
that's
angles are the same, so that means all
I
the
didn't
sides
know
need to be the
seven
same.
was there.
Yeah. So now let's go over to the other side. What type of triangle is this? Well, it's not very well drawn to scale. Don't critique my diagrams.
Isosceles.
We have two congruent angles, which means we're going to have two congruent sides. Where are the two congruent sides going to be?
Oh, they're gonna be 7 because it's.
So
Same as
opposite
that.
this angle means this side is going to be congruent to opposite this angle, which gets us to that side. So this is y plus 4. What's the length of this side? 7, because it's equilateral. So give me an equation to solve for y.
3 plus 4 is 7.
Well, 7 equals y plus 4, so y would be equal to 3. So y is equal to 3, and we said x was equal to 7. But I'm running over top of myself. Okay? Isosceles,
How'd you get to 3? Oh, it's okay.
just subtract the 4.
Yeah, no, no.
Simple enough?